Let's explore the fundamental concepts of work and energy in physics. Work and energy are closely related concepts that describe how forces cause objects to move and change. Let's start by understanding what work means in physics. Work is done when a force is applied to an object and causes it to move in the direction of the force. The work formula is W equals F times D times cosine theta, where F is force, D is displacement, and theta is the angle between them. Here we see a box being pushed by a force F across a distance D along a horizontal surface. Work is measured in joules, where 1 joule equals 1 Newton meter. 1 joule is the work done when a force of 1 Newton moves an object 1 meter. Work is only done under specific conditions. For work to be done, 3 conditions must be met. First, a force must be applied to the object. Second, the object must actually move or be displaced. Third, the movement must have a component in the direction of the applied force. On the left, force is perpendicular to motion, so no work is done. In the middle, force causes motion, so work is done. On the right, there's force, but no motion, so no work is done. Now let's understand what energy is. Energy is defined as the ability or capacity to do work. Energy exists in many different forms, including kinetic, potential, thermal, and chemical energy. Energy exists in multiple forms: kinetic energy of motion, potential energy of position, thermal energy of heat, and chemical energy stored in bonds. Kinetic energy is the energy of motion. Kinetic energy equals 1/2 mv squared, where m is mass and v is velocity. The faster an object moves, the more kinetic energy it possesses. Compare 2 identical objects. Doubling the velocity quadruples the kinetic energy because velocity is squared in the formula. Potential energy is stored energy due to position. Gravitational potential energy equals mgh, where m is mass, g is gravity, and h is height. The higher an object is positioned above the ground, the more gravitational potential energy it possesses. An object at greater height has more potential energy than the same object at a lower height. The work energy theorem connects work and kinetic energy. The work done on an object equals the change in its kinetic energy, which is final kinetic energy minus initial kinetic energy. When work is done on an object, it directly changes the object's kinetic energy. A force does work on an object at rest, increasing its kinetic energy and causing it to move. Energy cannot be created or destroyed, only transformed. The total energy, which is kinetic energy plus potential energy, remains constant in a closed system. Energy continuously transforms from one type to another, but the total amount stays the same. A pendulum demonstrates energy conservation. At the top, high potential and low kinetic energy. At the bottom, low potential and high kinetic energy. Power measures how quickly work is done or energy is transferred. Power equals work divided by time, or energy divided by time. Power is measured in watts, where 1 watt equals 1 joule per second. 1 watt is the rate at which 1 joule of energy is transferred per second. Let's summarize the key concepts of work and energy. Work is calculated as force multiplied by displacement in the direction of the force. Energy represents the capacity to perform work and exists in multiple forms. Kinetic energy depends on an object's mass and the square of its velocity. Potential energy depends on an object's position in a force field, like gravity. In closed systems, total energy remains constant, though it transforms between different types. Power quantifies how quickly energy is transferred or work is performed.